Welcome to another CO2 Monday in the Refrigeration Mentor podcast. I'm your host, Trevor Matthews. This week, I got a couple special guests. I was actually with their team down in Baltimore last week during the FMI event, and we had some good conversation there because we know CO2 is continuing to grow, and controllers is one of the things that we still need to consistently learn about because it's always changing. There's new developments and there's new manufacturers. And this week, I have two really smart experts on controls. Chris Prom, he's the technical manager, sales manager, as well as Cody Hamm, who is I believe, the technical OEM manager. And these guys, they know controls and they've been dealing with CO2 for years and years. And they've been doing some startups and they've been doing some commissioning. And when I started talking to the RDM team, the Resource Data Management team, they're like, these are the two guys we want to have on your show because they can talk the ins and outs of controllers, of setting up controls for CO2 systems, because this is who we're looking for. We're looking for the experts to help us walk us through this because over time, we're going to see more and more stores with RDM. My friends out in New Zealand, we did a podcast with James Darby last year, I believe, and New Zealand has a ton of RDM. And I know in the southern states, there's a lot. Even here in Canada, there's more and more RDM systems. Chris, Cody, welcome to CO2 Monday. How you guys doing?
Good. Thanks. Thanks for having me.
Good. Thanks for having us.
Awesome. Chris, why don't you do a little introduction of yourself and your role at RDM?
Yeah. So my name is Chris Prom. I'm one of our technical sales engineers. I got my start at RDM in 2012, and I worked at RDM until 2017 in tech support, so about 5 years. I then went to work for an energy management company called Q4 Energy Solutions, and we were pretty much exclusively doing RDM setup programming for grocery stores, C-stores, all sorts of applications. Just came back to RDM myself in July, and I'm happy to be back here.
Congrats. And how about you, Cody?
I'm Cody Hamm. I'm started refrigeration service. Let me back up. I'm the technical OEM. I work with a lot of the manufacturers, rack manufacturers, for the controllers and transcritical operations, all the way down to, DX rack systems and what our controllers can do and what they can't do. And I work with them on how to produce an outcome that's stable and easy for technicians to work on, service, so on and so forth. But basically, I got started in the refrigeration industry, probably knee high to a grasshopper with my dad and granddad. We worked on the Albertson stores, Tyler equalizer racks, all that business. Started there and just took it on from there. Learned from a real smart engineer on CO2 stuff for ammonia / CO2 from a guy named Zach. He kind of trained me on CO2 side of things and got me up to speed on transcritical, and I just took it from there. And then been working on a lot of microthermal E2 all the way up to pretty much any controllers that was out there. I started learning myself and teaching myself. I got my own test lab here that kind of put together everything and test this. But that's just a short summary.
Yeah, no, we were talking, I think it was 2 weeks ago, you were doing a startup of a transcritical store, helping out an OEM at that point. So that's pretty awesome. I'm going to start with you, Cody, first. What do you find are some of the key things when you're working with an OEM to help them the best to get your controllers involved and integrated with their system? Because I know that's a big project, right? Working with a manufacturer, getting the things right. What are some of the key things when working with an OEM that you try to help them with?
A lot of it, what we run into is oil injection, the flash gas valves, the high pressure valves, kind of how our controller works as far as that goes, what the technology in it is, what the PID settings are, what the background of it does. Sensor placement's a big deal. What kind of gas cooler we're working with, what kind of, controllers we're working with. It all goes together as one. And so what I do is we kind of go through their IO schedules and we kind of look at what kind of criteria, what design are we looking for the outcome and what the individual is looking at. You take this system versus this system in this environment, what's going to be totally different to this environment in this particular situation. What we do is I go in there and I try to work with them on IOs and scheduling and sensor placements and where to put this, how to do this, and how our controller is going to benefit them in the end.
Yeah, I love that. And Chris, I know you've been doing tons and tons of technical support for the RDM product over the years and even on CO2. What are some of the things that technicians like a lot of the calls that you get for the support for CO2 systems?
So CO2 systems, I haven't done a whole lot. That's more Cody's thing right now. But I've done hundreds of like standard HFC racks, and it's probably very similar in where you'll see maybe sensors being misplaced or miswired. We've had a lot of issues with just like run proof inputs being swapped around for compressors, and then compressors will get locked out, and technicians are just kind of like, well, the program, something's wrong with the program. And what it really is it's actually OEM wiring that's wrong.
Could you explain that a little bit just for everyone that's listening on that exact process? Because it's not only your control. I hear the exact same from other controller manufacturers. You want to just explain that, the process for that example there?
Yeah, so run proofs for our controller, say your first compressor is on relay 1 and it turns on and run, you then set up a status input for that controller saying this is the run proof for that compressor. If it doesn't return a closure or an opening, it's usually a closure, but if it doesn't return a closure on that status input within a delay period, it will, depending on settings, it can lock that compressor out, or it will retry to restart the compressor several times. And then if it fails, it'll lock it out. It might happen that you turn on a suction group and it seems to be running fine, but it's actually like going through that run proof process, and then it locks the compressor out and throws an alarm, and then it'll move to the next compressor and it'll lock that one out after a while as well. And what you'll find is that those two compressor run proofs were completely swapped around, and that was the issue the whole time. We actually run into a lot of that. I've spent way too many hours on the phone just trying to talk through that whole process with people. It's amazing what just a couple wires being swapped at the factory can do. So
for sure. So it's just the wiring. That's it, right? The couple wires.
Yeah. Just a couple wires.
Cody, what about you? What you doing a lot of the technical support now on the CO2? What are some of the calls that you've been getting?
I get a lot of the proof lockout thing. To touch base on it, Chris is correct. So we'll see wiring incorrect or that first, vice versa, and then you'll also see the other thing is we're still running off mechanical. So our controller, all it's doing is sending a signal on off relay. You're still running through time delays, you're still running through low pressure switches, you're still running through all that wired up. Well, what'll happen is in our settings, we have time settings in there. Well, the OEMs will set them during testing period. They'll set them to 5 minutes, 2 minutes, whatever, and they'll leave them. Well, if the startup guys don't realize that those are set to that purpose and that our equipment's set for 1 minute return signal, it locks stuff out. You got to understand that there's a lot to it and a lot that goes on. It's not just controls. You also have to look at mechanical side of things too. And so what happens is this time delay set for 10 minutes and it doesn't see that signal to come back, it's going to continue its cycle and so on and so forth. And then I get a lot of calls on just racks not fine tuned. Cases are flooding out. Cases never got checked right. You've got iced up compressors. CO2's, it's a cold refrigerant. It is what it is. And if this isn't set right, now we've got flood back. Now you've got your flash gas valve going all over the place hunting. And then you got your high pressure hunting all the time. The gas cooler was never set up correctly. I get a lot of that going on, and it's like, okay, let's take it one step at a time, and we'll start here, and then we're going to move on down the line.
I think that's important because what people need to understand, I talk to them a lot, and like I said, a lot of different controller manufacturers, the same things happening with them as well. Is like there needs to be this recommissioning or not fine tuning after the store is installed as well, because I've seen this tons and tons of time going out with actually an OEM to a site and they haven't been there for 3 or 4 months after the store has been started up, and they go through this, we get into the controller and look at the controller and nothing has been fine tuned to that actual system or that case. They're just using the defaults, right? So that's really important. Thank you, Cody, for that. Chris, why don't we just dive into some of the information you have here on the screen, and I'll walk anyone listening to, I'll walk through some of the stuff.
Just a few slides to kind of cover what we're going over today. We're going to be looking at a couple of live sites. One site it's a system. It's a Lunds and Byerly's site that has a CO2 system. I think it has FTE stuff on it, Cody, if I'm not mistaken. There's another, there's another system we're going to be looking at that's just a standard like booster system.
So when you
but
say,
we're going to be looking
sorry,
at,
Chris, when you say FT, that's Kaiser Warren full transcritical efficiency site.
Correct.
Okay, cool.
So we're going to be looking at our transcritical controller. We're going to be looking at case controllers. We're going to be looking through our data manager, which is our front end kind of data aggregation front end system. The data manager is not necessary for control of a rack or associated cases at all. The case controllers and the rack controller all have their own programs, their own brains. They don't need the data manager, but it's great for getting all of your data in one place, getting into a site, doing things with your alarms, things like that. So the transcritical controller that we're going to be looking at, it's for setup of like a medium temp, low temp suction group, your gas cooler receiver, so your high pressure valve control, your flash gas bypass valve control, oil control. You can do parallel injection, either parallel or separate from a flash gas bypass valve. And then the controller also has 3 general sections where you can set up general functions for like controlling a relay off a temperature or a pressure or a time, or an input signal, things like that. So if you need to do anything kind of extra that's not really supported in the controller, you can still do that. The controllers have the options to use all sorts of different sensor types, like 10K2 is really common. You might see PT1000. I think 10K2 is becoming more used. I don't know if it's just the higher like resolution, because you're not dealing with just several thousand ohms, you're dealing with tens of thousands of ohms in that range. So maybe it's becoming more popular for the kind of sensor resolution. I'm not really sure.
So Chris, what can you explain the difference between, because lots of people know what 10K is. What's the difference between 10K and 10K2? Can you explain that?
So at room temperature, very little. I think it's something like 200 ohm difference. The difference comes into play when you get fairly cold. Your resistances are quite a bit off, to the point where you can be reading 4, 5, 6 degrees off at a colder temperature if you have your probe set wrong, or if you're using the wrong type. So it does matter for those, below room temp applications for sure. At room temp, you're almost not going to be able to tell the difference between the two.
Yeah. And this is the big thing I talk about with a lot of people, because I didn't know about this, like, oh, a 10K sensor is a 10K sensor. But no, even if they're 10K sensors, they'll have different resistance charts. Some are fast acting, some are slower acting, even though they're a 10K, just like you said. So that's a very good point that you put out there. Thank you for pointing that out.
I think there's also a 10K3, so have fun with that one. It's a 10,300 ohm at room temp, so it's slightly different. But and then for our universal inputs and outputs, they're selectable on the controller, where you can use a 4 to 20 milliamp 1000 span transducer. If you can't find a 4 to 20 milliamp, it's important for technicians to know, if all you can find is like a 0.5 volt to 4.5 volt, that's the same span or a different span, as long as it's a usable span, you can actually fairly easily in the controller change those settings and use that transducer instead. I've had technicians call and ask if you can kind of do that, and I've had to walk them through how to set that up. It's not common, but it does happen where that comes into play.
Yeah, so that makes it a lot of versatile, because there's sometimes you can't get the transducers. You guys build your own transducers and stuff, or is that, it doesn't matter? Is it all outsourced?
We have ones that we sell. Yeah.
Okay.
We do have ones. And they're generally going to be a 4 to 20 milliamp.
Yeah.
There's a 760 span all the way up to like a 2000 span that we generally use.
Very cool.
Yeah. Can I touch base real quick on while we're going over the controller, the STCO2 and controllers in general? I do want to make this pretty clear. This is what I like about RDM and the controller standpoint. It's simplified. The flexible combiners and running math and doing all this and building all this in the background, and that's all gone away. This is simplified. This is changing a couple of things around, moving some mapping around, and doing some real simplified stuff. So once you get to know it and know what you're looking at and get familiar with it, it's very simplified in troubleshooting and changing some stuff around, instead of spending 2 or 3 days going through and rebuilding the whole flexible combiner on a rack. You know what I mean? So this is way more simplified on that aspect of things.
Yeah, no, and that's the thing is like the people that I've talked to that start to use RDM or used RDM before and then went on to like microthermal or an E2, they said it's just procedures, just like the flexible combiners, makes it a bit easier to use RDM because it just takes that out of it. You mentioned it there because you said you worked on microthermal E2, Danfoss, all those controllers. So and that makes a big deal because flexible combiners are difficult to think. You can figure it out. It's you have to write it all out, and if you didn't write that code, it's like how do I figure out this map, right? So
Yep.
Yeah, and then there's variants of this controller. So there's a 650 style, which is just like the software for doing control. There's also a 652 variant of the controller. It has two stepper outputs on it for your high pressure valve, your flash gas bypass valve. You can do stepper type valves, or you can do 0 to 10. And you can also do there's a third option for like a heat recovery, heat reclaim valve. You can do that either 0 to 10 or stepper type as well. For OEMs, this is great if you needed to connect to like a third party front end or something. The controllers do BACnet IP as a software option, so you have that available if you need to.
I know BACnet is becoming more and more involved in refrigeration, kind of like it is with HVAC. It's BACnet's huge in the HVAC industry, and we're finally starting to see it in the refrigeration industry.
Yeah, I definitely prefer BACnet to Modbus. Just BACnet has that kind of self-actualizing where it just sends things, and it should work ideally. Sometimes companies don't exactly follow the standard, but Modbus, you have to like write your own templates. And you can do that in the data manager if you need to do that, but it's kind of tedious to go through all your registers and write all that stuff out. So when we're talking about setting up a suction group on the transcritical controller, you can do a medium temp, low temp group. There's options in the board for either staged logic, which is logic people might be used to seeing, which is compressor 1 comes on, then 2, then 3, then 4. I don't think I've set a rack controller up to do that in like 10 years. We use our fuzzy logic algorithm, I think almost exclusively. And that is going to stage your compressors based on, you put in your compressor control relays, you put in your compressor sizing. There's various other settings for like other things you might want to do, and we'll get into that. Fuzzy logic just knows based on pressure, based on runtime, it knows what compressor it can stage next, what compressor it should stage next. So if you have two compressors that are the same size, like maybe 2 and 4 are both 15 horsepower, if 2's been running a lot longer than 4 has, it might say, I'm going to let 2 kind of just have a break. We're going to run 4 instead. And then if it needs 2 again, it'll run 2 again. And then if in some of these settings in the controller, both for suction groups, the gas cooler group, receiver control, as well as our case controllers, you have these fairly ubiquitous kind of set points that are called response on, response off. And then you have inverter min max ramp as well as inverter hold. These are all going to be settings that are really useful for if you see your suction pressure or your discharge pressure or a valve's opening too fast, too slow, you can kind of dial these numbers in. Like response on and off is a 1 to 60 value. 1 is the slowest, 60 is the fastest. You can start by just setting both response on and off to 30 or 15 or whatever, and that'll probably get you right about where you want to be for control. But if you're seeing kind of, spikes that you don't really like, you can kind of dial those parameters in to try to, control how it's modulating. It's a little more intuitive than if you have to learn PID, like learning what a proportional constant, an integral, derivative, learning what all those things are, and then how to fine tune PID. I wish you luck. If you're not very good at math, that stuff you can get pretty involved in that stuff and get kind of lost, and you end up kind of like just setting random set points, and maybe you get lucky and get what you want to get where you wanted to be.
The thing is, I hear this a lot, like, oh, I need to go in and fine tune the PNID. How often after a store is set up, right, the control guys go and set up, should technicians be touching a PNID? Cody.
No, now you get a manager in there or what I call a high technician or something like that knows, you know what I mean, and is read up on it. Because here's the thing with these settings is what Chris is talking about. Response on and response off time, case level, that's all great. It does make an effect. I'm not going to lie. But when you get into the transcritical portion of it and you're talking about valving and high pressure and flash gas valves and everything else, I've walked into a controller that they had these things turned all the way up to 60. I walked over there, pulled my manual valve out, and it had lost its steps because 60 is extremely fast. It's extremely fast on the response time. And what'll happen is it'll send that signal to that valve, and that valve's trying to speed up, slow down, da 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 da, and then finally it just loses its steps. And then you'll look at the graph and the chart, and you say, well, it's saying it's at 570. Well, it ain't at 570. It's actually at 1260 or vice versa or whatever.
Mm-hmm.
You just got to be real careful with these settings, and you got to know, you got to watch this stuff, and it doesn't happen. It's not an instant deal. It's you're going to change this by, 5 or 3, and then you're going to let it run and watch it. Watch the graph. Sometimes it's instantaneous and you'll see it right away. Sometimes you got to wait. Graphic, come back the next day, check it out, see what it's doing, and then fine tune it from there.
Yeah. And I like that you don't just change stuff and then change it 3 minutes later, and then change it again 3 minutes after that, because you need to see the effects of it, because that one, especially like the flash gas bypass valve or the high pressure valve, that affects all the other valves. That's changing your flash tank pressure, your receiver pressure. That's going to affect all your medium temp valves, your low temp valves. So you got to wait and you got to watch it. Just get back to this response on and response off, just really quick. That would, in the slide, it says for frequency drives, but that could be for your case controllers, for your electronic valves. Is that correct? So this is not just for the drives. This could be for any specific component that has a opening percentage or up and down ramping.
Yeah, so you'll see it in suction groups, and that's going to refer to your VFD. If you see it in a gas cooler group, it might respond to either your gas cooler fan output or the valve or the receiver valve. There's settings for all of those things in there. And you also will see it in case controllers where you can dial it in for valves. So it's kind of
so it's a way to dial it in without having to change the PNIDs.
Right. Yep.
Because most control manufacturers I talk to, the PIDs do not really have to be touched. They shouldn't be touched, because you guys fine tune them with the OEM or with the manufacturer of the equipment. So when it gets out to the field, the technician the control guy should be able to install it and not have to play around with it. But that's why there's commissioning and startup. Maybe there is a little bit of fine tuning that those guys that understand controls need to change a little bit. Is that correct?
Yeah, exactly.
Yeah.
Awesome. A lot of our customers actually, they'll say, I want the case controller response on and off set to this for every case, period. And they'll just leave it at that. And then if they do see a case where they maybe think it needs to be tweaked, they'll then change that. But honestly, you don't see techs using these too much. If they're trying to accomplish a goal and they really know the system, you might see them messing with it, but usually they don't need to.
Yeah, I think Trevor, I've seen it one time where we actually had to it was just a mistake. It was an overlook, kind of over-engineered type situation, and the valves were just enormously oversized. And I tried everything I knew to do. I mean, I did this, we messed with this, I tweaked on this, I turned this down. We did everything, and I finally looked at them and said, look, we're gonna have to build a TDB PID structure and put it in here, and we're gonna have to set that up. And that's what we had to end up going with. But I've seen that one time, and I haven't seen it since.
So it does happen, but even with all the other manufacturers I talk with their controllers, they're set up for, like, they're designed them for it. Now there's so many years with the experience with CO2, it's not new anymore. So you guys are building the back ends a lot better than 10 years ago. So
when we're looking at the sites, you're going to see a gas cooler section. That's going to be controlling your gas cooler fans, your high pressure valve, your receiver valve. If you had parallel compression, you're setting that stuff up. Heat recovery, hot gas defrost. That stuff's all kind of optional that you can set up. Got all your usual temp sensors, your cooler inlet outlet, your ambient. All that stuff can kind of be set up in those sections. And like I said, there's 3 stepper outputs. You can do your high pressure and your flash tank, and you can do heat recovery valve. A lot of times, I think, just by the nature of how OEMs how things get ordered from OEMs. They'll have a rack with a rack controller, and then they have like a glycol loop heat reclaim system, and they don't use our heat reclaim on the rack controller. They'll actually use our TDB and write their own program. And I think that's just by nature of how things are ordered and kind of logistics there. But you can do heat reclaim with these controllers.
So with this one control, your one STCO2 controller, you can do 3 valves off that. You don't need an auxiliary pack or anything like that.
Correct.
Or module, sorry. Okay,
Yeah.
cool.
Yeah, your only limitation really. So if you had 2 steppers on your main board and you needed that third, then you'd have to buy a little stepper expansion module. Or if you wanted steppers that had auto close, we have stepper expansion modules that have auto close, so you don't need to run like an uninterrupted power supply. They just have a little capacitor on board where they detect a failure in the power, close the valve down, and then they go to sleep too.
Yeah, because I see on larger systems where they may have redundant valves. So they might have 2 flash gas bypass valve and 2 high pressure valve. That's where you would have to have that extra module or expansion pack for the other valve. Cool.
Yeah. Oil injection is pretty simple. It can be done via status inputs. There's an oil separator input. There's high, low level inputs. All this stuff is like configurable. You can use whatever status inputs you want. So you can control off and enable input. You can pulse it via timer. There's various settings you can do. It's pretty simple. That's not a very complicated section to set up, really.
How often do you guys see using oil injection control? Because there's many different designs. There's oil with solenoids. There's oil with high pressure oil in with the oil level controller. So when you say oil injection control, what is this controlling, and what type of oil management system would it be?
It's Trevor, it's a pulse valve is what normally we're seeing right now.
Okay.
Basically it pulses every 5 seconds, stays off a minute, pulses again. It keeps the oil separator, it keeps it full, keeps oil in there, keeps things rocking and rolling, keeps pressure in there. That's the only thing that I'm working with our UK right now. I would like to see that a little bit more fine tunable. I would like to see it pulse for, 5 seconds, 8 seconds, whatever. But instead of staying off a minute, I would like to see it stay off for about 3 minutes or so, give or take, and then pulse again. There's certain things I'm starting to see in the field on certain applications that's too much pulsing, and it's like you'll fill up and then, it has nowhere to go. And so I'm seeing a lot of that, but that's what we're seeing right now as far as the oil section is concerned. Other than that, it's more relevant for it's basically simplified into like oil failure controls instead of putting that into your status inputs and taking up space into that. And you can put all that towards the compressor and oil failures and things like that nature is basically what it's for.
So Cody, just so I get this straight, you have your oil separator. So you get your oil separator there. From the oil separator, the solenoid between the oil separator and the oil reservoir, that's what's pulsing on and off?
Correct.
Okay. And then you're filling up every 5 seconds. You're emptying this the solenoid, the separator to the accumulator. Not
Correct.
Accumulator, sorry. Reservoir.
Yeah.
You're just trying to talk this out, not looking at a diagram. But okay, perfect. I totally understand.
We're also going to be looking at some of our case controllers. Case controllers are very similar in that they control a case. That's what they know to do. You can use various different probe types. There's a caveat with any of these controllers. If you're using one probe type, that has to be your probe type for every probe. You shouldn't intermix probes anyway. It's probably a bad idea. You can get all sorts of weird readings going on if you get things crossed. But our case controllers, we have single, twin, and tri-coil case controllers. So our single and twin is going to be like our 740, 750 Mercury and Intuitive line. Our 3-coil case controllers, the PR0680 3EC controller, that's seeing a lot of use these days for like some of those 12-foot cases that are 3-4 foot evaporators. I mean, they're installing a lot of those controllers.
Yeah.
So technicians are going to be seeing a lot of those. One thing to look for with those, especially during startup, sometimes valve wires can get swapped around, or suction sensors can get swapped around on each coil. So then they'll kind of control off of each other. So you'll see a valve that's completely closed, but the superheat's really low. And another valve, the superheat's really high, but the valve's way open. You pull a graph and they're just like crossed with each other. And you can that's a very good indicator that you've got something cross-wired. That happens not infrequently.
Yeah, I know, because the big thing now with CO2, there is so many more temperature probes, pressure probe, which is great for us after it's set up and commissioned, because now you get so much data, you can troubleshoot
Yeah.
so easily. Like if you have a site, Cody could just jump on with you or Chris in a few minutes, and after you learn the trends and how to watch the percentage of the valves opening and things, it makes life so much easier to troubleshoot compared to
Yeah. And
back
I
in the
think
day.
James, when you talk to James Darby, I think he touched on this, that you can use either local pressure transducers, or you can use a remote pressure transducer reading from the rack. If you're doing a remote transducer from the rack, I'd say make sure you always check with gauges at your suction, at your case. Make sure that there's not like a pressure differential there. I'll see people use remote rack pressure and then they don't even check, and then you might be off several pounds, which is going to throw your superheat off, which is, maybe you have flood back if it's really bad.
Good point.
I see a lot of local transducer. That's my preference, because even then still you're going to want to make sure it's reading right on for suction. Maximum operating pressure in our case controllers, that's going to be, the case controller doesn't have to talk directly to the rack controller. If it is, then they're sharing the suction pressure. But if they have their own local pressure transducer and they see that the suction pressure is getting, maybe we're 10, 15 degrees above saturated for our normal suction pressure, you can tell that valve to go to 50%, 20%. You could tell it to close entirely. And it's a way that the case controller can help the rack, kind of try to recover its suction pressure. There's also features in the data manager I want to get into for product priority and CO2 load shedding. So for product priority, when you have a pressure event where your suction pressure, maybe it goes too high, maybe you've got a run proof as well, you can go off various different fail conditions. You can actually shut all of the valves on all of your controllers until this condition has kind of remedied itself, and then it will start staging cases back on by priority. If you have ice cream on a low temp group, that's going to be really high priority. You're going to want that running before maybe like a frozen bakery case that doesn't have as much valuable product in it. CO2 load shedding is almost kind of the opposite, whereas if you have a failure, it will take your lowest product priority. So produce, beer, wine, stuff that's not as susceptible to temperature, it'll actually, you can load shed off those cases to maintain your suction pressure on higher dollar things like meat, dairy, cheese, stuff like that. And I think it's the priority is like 1 through 10. So you get 10 different priority levels, with 1 being the highest priority. You can also send TDB commands from our data manager. So you could actually, if you think about it, you could preempt load shedding by looking at, your suction pressure, and maybe before you've even got like a run proof alarm, you notice your suction pressure is a little high. You could send a valve divider command to those produce cases and say, hey, go to 50%, go to 25%. Like we're going to let you kind of run a little bit, but not too much, because we're really worried about suction pressure being maintained for our higher priority cases. You can do things like that. Optional, but you can do it.
How often do you see stuff like that being used?
Product priority is used a lot. It's especially used in CO2. I've seen it a lot in cascade sites, because if you lose your medium temp group, you're going to lose your low temp group. And then you might want to write a little custom thing where you start staging priority for your low temp first. So you get your low temp, or your medium temp first. So you get your medium temp running, get that all good, and then you start running your low temp. You don't want to start prioritizing your low temp and running that, and then your medium temp's not running. So navigation for techs, I highly recommend, if you're working on an RDM system, have a laptop. You can do a lot through the front
Any
screen.
any controller, you need a laptop. Like
yeah. I run into a lot of technicians that they're just like, yeah, we don't get supplied a laptop, and I'm like, I'd go buy one, and I don't know, figure it out on the back end there. But like I said, you can do things through the touch screen, and like if you need to change a set point or whatever, it's pretty easy. But if you're going to be doing commissioning entire sites, programming racks, you're going to want a laptop. The data manager is really easy to access. If you open the right side panel wing, there's 4 Ethernet ports there. You can plug into one of those on your laptop. The data manager then assigns your laptop an address, and the data manager IP address is 10.1.2.7.5. Almost every time. You can change it, but I very rarely see it change. So that IP is going to be very useful. Or if you're going directly to a rack controller over like a printer cable or Ethernet. It's that 10.255.255.254 address that'll get you right into a rack controller. Or if you have rack and case controllers on a data manager network, you can go to the device tab and then device info, and it will show you the IP address of every single controller that's on that data manager. And if you're plugging into the data manager, you can then use that IP address to get to any controller. So if you are, your rack's on the roof, it's 100 degrees outside, you'd rather be inside in the air conditioning. You can log in to your rack controller that way. I've definitely been on that side of things before.
So those of you that are new to controls, this is a lot. Talking about IPs and all these numbers here, it does take a little bit to learn. I know I've done it when I was working at Emerson, getting into the Dixels and getting into the E2s and stuff like that, connecting the computer to it. But there is documents, like RDM will even have documents that walk you through it step by step on how to do this. And you need to do it a couple of times. It sounds difficult because you're listening to it or watching us right now, but it's something that if you do it a few times, it's pretty easy. And every controller, just so everyone, every controller manufacturer, same thing. You have to get the computer to talk to the controller. And that's what you're doing.
And then alarms happen locally at controllers, case controllers, rack controllers. But if you have a data manager, all your alarms get pushed to your data manager. At that point, you can do, back-end network stuff. You can set up all your alarms can be sent over email. They can be sent over text messages to various, you can send them to, a service email for your service company. They can get all the alarms. A lot of our customers are opting to use ActiveFM, which is our website portal where you can put your entire enterprise. If you have 100 sites, you can put them all up on ActiveFM. You can get remote access to them. You can do alarm monitoring. So there's some of our customers will have alarm monitoring set up where if they get an alarm, someone in our call center will actually dial in. You might get a friendly call from a Scottish lad or lass who you maybe can or cannot understand, but they're going to let you know there's an alarm on your system and maybe you should do something about that. And we're actually going to be using ActiveFM to dial into sites today. Graphing, I like graphing on this system. It's really fast. You can pull a lot of data, like pulling a 48-hour graph snippet is really quick. It's like seconds. If you want to pull a week, 10 seconds, 15 seconds. The data manager stores up, I think it's up past 5 years of data. So you can actually look way back in your system to see, what happened last year during this time versus what's happening now. We'll touch a little bit on TPI. That's our predictive algorithm for what a case is doing. It's a 1 to 10 green to red kind of scale that you can use, and you can actually alarm off of it. If your case is having an issue maintaining temperature, you can throw an alarm before you're even an overtemp alarm. A lot of times when a coil ices up, you will be displaying issues with temperature in that case well before you're alarming. And you can use that kind of TPI alarm as an indicator to get someone to look in to see if a case has an issue.
So with the controller itself, you can get this graphing with the data monitor. It's additional. Is just more graphing, or it's just all in one place and there's more features to it?
If you were to pull a graph on like a rack or a case controller, you can do that internally. If you have everything mapped to a data manager, then all of your data is mapped and you can overlay graphs. So you can graph out your rack suction group and then overlay cases into that and see what each case was doing.
Yeah.
You can do a lot of different stuff. I don't know. It's not, I don't write the checks, but I'd always recommend having a data manager. It's nice to have. They're really cool.
Oh, being able to see the trends, the graphs, overlaying stuff makes a massive difference.
Yeah.
When you know how to read it. It does take time. Yes. The first time you see it, it's like, what am I looking at here? It's just a bunch of lines. But when you understand, you can look at the percentage of valves opening, you look at the suction pressure, you look at the ambient temperature outside, depending on what you're looking at, right? And it does get easier. Troubleshooting, I think, for technicians, like more and more technicians are going to enjoy working on CO2 systems versus the HFC systems.
Yeah. And the CO2 systems, there's a lot of interesting graph data. If you just graph like ambient here, it's like 55 degrees right now. So some of these sites, you can see like how the flash gas bypass valve like modulates down really low because you're not dealing with as much vapor that you have to get rid of in those low ambient conditions. So it's cool to kind of go from like a 90-degree day down to like a 55-degree day, which happens a lot here in Minnesota. That happens basically every other day. So, and then we have these little graphical, like the It's little graphics of the CO2 rack here. This is something I made for a customer on a startup we just did recently. So you can actually build these like graphical interfaces with our layout editor software. I think these are really cool, especially if you're trying to train new technicians, because now you're giving them like a visual representation of what's going on. You can, go through it with them and explain how everything works. It's pretty cool.
So this software, is it free to build a layout, or do they have to pay for this?
The software is free. This software in particular, we ask that so you have to get it from tech support. We ask that you take a small little training course on it.
Yeah, makes
The
sense.
reason being is it works directly with the data manager. So if you don't know how the data manager works and you download the software and you think, oh, I'm going to use this software for building a graphic on this other system. Well, it doesn't work for that. It's for the data manager, or it's for our rack controllers.
Yep, perfect.
And then we'll be mentioning TDB. TDB is our custom PLC editor. We use it a lot for all sorts of things. We have canned software for racks, like a CO2 rack or case controllers, but we use PLC for like scientific blood bank panels, C-stores, restaurant, all sorts of things. I've used TDB for the last 10 years, probably more than anything. TDB comes into play when you're talking about rack controllers and case controllers, because you can use it running on the data manager to send those custom things like a valve divider program. So you can limit those valves if you want to under a pressure condition. Comes in handy for those, but it's completely optional. You don't need to buy it. You don't need to do anything with it on your data manager. The editor itself is free. You can go to our website right now and go to our software tab. It's like one of the first links you'll see. And if you're interested at all in PLC, you can just download it and start playing with it right away. You don't need a controller. You don't need to pay for anything.
Awesome. And so that's where they can start like building their own like little logic. Is that right?
Yeah.
So
and
you
works
do
with all
this, this relay closes, now a fan turns on. So this is for people. This is great for people who want to start learning. I love that. Who want to start learning about how it controls, right? And I think it comes back to getting into softwares like this.
Yeah, I think it'd be great for, if you were a teacher at like a technical college and you were training PLC, well, this is free. You don't have to buy anything. You don't have to worry about anything. You can teach your students PLC with this. And I think that's really cool.
Just real quick. So speaking of TDB and how complex you can get with it, which you can go way complex with it. But so I'm not going to mention any names right now, but there is a very smart engineer that when we were doing cascade and CO2 stuff, and we always had cascades fighting each other and medium temp and low temp, we just had too much going on, and it could never get perfect like the way I wanted to see it. And so we started discussing ways, and I told him, I said, well, why can't let's build something that runs off loads, And so this engineer designed it off a TDB structure. And basically what happens is now the cascades run off the medium temp load versus the CO2 load. If we don't have a lot of load on the CO2 or load on the medium temp or whatever, we're going to kill one of those cascades off. We don't need it. He went in there and built all them custom blocks and all that custom stuff in there and made that work. It works really well.
And this goes off of function blocks. Is that correct? Is that what you call them?
Yes.
Function blocks? Yeah.
Yeah, it's like Boolean logic, kind of ladder logic, where you're putting blocks down and drawing lines and statements or statements, stuff like that. Yeah. One thing I really want techs to know, if you're involved with like replacing a board, if you have like a case controller failure or something, the easiest thing to do for a rack controller, if you're setting up a rack controller, or if you are commissioning a site you can take like a USB and just plug it into the data manager. If you see in the top right corner, there's a little USB on that data manager there. You can plug a flash drive into there and it'll immediately prompt you to save the site, and username and password, you can save the whole site. So if you're worried about, maybe you need to make some changes, but you don't want to screw anything up, you can save the site and then make your changes and go, oh, I want to back out of this. I don't know what I did. You can just put your flash drive back in, re-upload it. It's like nothing ever happened. If you do run into a situation where you're replacing like a rack controller or a case controller, the best thing to do is to make sure that controller is set for the same control type. So if it's a rack controller, make sure it's set for fuzzy logic. Make sure it's set for 2 suction groups and a gas cooler receiver control group. If it's a case controller, make sure it's set for a case and not a cold room. And then set the rotary IDs to identify the controller to the data manager. Then plug your CAT cable in. And if you have locked parameters, all the parameters in the data manager, you can kind of save them and lock them in place. The data manager will see that new controller that might not be programmed at all. And it will go, oh, hey, I recognize this controller. You're the controller that's been offline for a while. Where you been? And then it will dump those settings back into the controller because it'll go, hey, my settings have changed. So you don't have to necessarily worry about programming. It can kind of self-program itself, but it is reliant on certain things like that rotary ID identification. If you were to set that to something else entirely, the data manager wouldn't recognize it as that controller. It just recognizes it as a controller.
So Chris, let's talk about, just say it's a case controller. Case controller, got a surge to it, fried it, or something like that. Yep. So what are the 3 things that they would need to put in? Because they'd have to power it up. You'd have to hook your computer up to that case controller. And then what are the 2 or 3 things they would have to do before they plug in the Ethernet cables to your?
It's Cat6.
Cat6. So before they plug into Cat6, what are the 3 or 4 things they need to do on the computer again?
On a case controller, there is, I think, literally 3 things they need to do. They need to make sure it's set for the right control type, which you can do this through the front buttons too. So the right type would be, you can set it for either a cold room type or a case type. Then you're going to want to make sure your probe and your pressure units are set. So if you're using 10K2 and PSI, you're going to want to make sure that's set. And then set your controller ID or your rotary dials. Yeah. That basically tells the data manager that this is the same controller, even though it's a brand new one. And then when all of it comes back up and the data manager recognizes that its settings have changed, it will say, hey, I have all your settings here, and it'll dump them back in. And then you can basically, at that point, if you did it right, you can walk away from it. It's done. It's already pre-configured itself.
Thanks for re-explaining that. And so then after you do those 3 things, then you plug in your Cat6 cable, and then everything is perfect. Good.
Yeah. I think some people do it in the opposite way. They might set the dials for like a completely different dial because that makes sense for some reason. And then they'll plug the Cat6 in. It'll come back on the data manager as a completely new controller that's not aliased. The settings aren't there. And then they're kind of stuck. They're like, well, I guess I'll just call tech support. What do I do? And then tech support's going to walk them back through setting it up properly and then just plugging in and having all the settings dump in.
Well, that's a great tip.
Any tech I talk to, I try to tell them that, because if they know nothing else, that's really helpful to know. That can save their day. And then we just got contact information. If you need to contact Cody or myself, got our emails. Tech support is it's USA support at resourcedm.com. General sales is USA sales at resourcedm.com. That goes to all of us in sales. The office number 612-354-3923. Option 1 goes to sales, 2 goes to tech support.